Good afternoon, everyone, and welcome to this lecture. In the previous class, we are done with your Newton laws, and now we venture into the next topic, and that is known as friction. Anyone knows anything about friction? What do you mean by friction? Any idea about friction?
The force which opposes.
Yes, beta.
The force which opposes, sir.
Friction.
The force which opposes.
Very hard for me to make out what you are saying. Friction is
The force which opposes the given applied force.
the force which opposes the applied force. Okay. Any other idea? I mean, it has to oppose the applied force.
Obstruction of the motion, sir.
Obstruction of the motion, sir. Okay. Obstruction of the motion, sir. Okay. Now, we have seen that whenever two bodies are kept in contact, what happens when two bodies are kept in contact? What happens if two bodies are kept in contact with each other? What happens when two bodies are kept in contact with each other? When two bodies are in contact with each other, what happens? We've seen this. We've talked about this. Whenever two bodies are kept in contact, they will interact with each other and they will exert forces which are electromagnetic on each other because of the interaction between the particles of the two bodies. They will interact with each other. Those forces are known as contact forces or reaction forces. So whenever two bodies are in contact, they exert forces on each other. This contact force is an action-reaction force. They act on the two bodies, but their directions are opposite. So these contact forces actually obey Newton's third law. They are equal and opposite. Now these contact force, which you can see drawn here, this R is the contact force. This contact force R can be resolved into two components. One of the component of this R is perpendicular to the two bodies. And this component is known as the normal reaction force or the normal contact force. You can also resolve this contact force into a component which is parallel to the two bodies. If in this case the body is moving towards left, there might be a force which is towards right, which is coming because of the contact between the two bodies. This component of reaction force or contact force, which opposes, what does it oppose? Which opposes the relative motion between the two bodies is known as friction. So what is the point that you must remember about friction? Friction is the parallel component of what? It is the parallel component of contact forces. Whenever two bodies are kept in contact, they will exert forces on each other. The parallel component of this force is known as your friction, which you can see here. Now, what is the work, or what does this friction do? Yes. Now let me ask the question again. What is the job of this friction? What does this friction or this contact, this parallel component of contact force do? What is its job? What does it do?
They keep objects in equilibrium, sir.
It keeps objects in equilibrium. Okay. What else? Anything else? It keeps object in equilibrium. As you can see here, this is an action reaction force. So if I draw this R will be the reaction force exerted by body on the surface. This N, equal and opposite N, would be the normal reaction force exerted by the body on the floor, and this F would be the frictional force exerted by the body on the block. So these are action reaction forces. Anyways, yes, what does this friction do? What is the job of this friction? No idea. What does this friction do? What is the job of this friction force? Wrong color. What is the job of this friction force? This friction force or friction opposes. What does it oppose? It opposes the relative motion. Sometimes there is relative motion, sometimes there is no relative motion. So it opposes the relative motion or the tendency of relative motion between the two bodies. Sometimes there might be relative motion. As you see in this diagram, the body is moving on the top of the floor or some table. There is a relative motion between the block and the table, and this friction is going to oppose the relative motion between the block and the table. It has got nothing to do with the applied force. It does not oppose the applied force. No, there is no force here for that matter. The force only is weight and mg. It is not opposing weight and mg. So don't say that friction opposes applied force. No. Friction opposes relative motion. Whenever there is a relative motion, sometimes there may not be a relative motion, but there may be a tendency of relative motion. Friction is that thing that opposes this. There is a common misconception that friction opposes motion. So remember, friction does not oppose motion. In fact, it is because of friction, motion is possible. So remember this, friction does not oppose motion. In fact, it is because of friction that motion is possible. You are writing on the book, I'm writing on this pad. It is only possible because of friction between this writing pen and the surface. If there is no friction, I would not be able to write. If you are on a ice slab and you try to walk on an ice slab, you will not be able to walk, you will slip because there is no friction for you to walk. Friction does not oppose motion. If your car ka wheel is caught in mud, the car ka wheel keeps rotating, but the car does not move forward. Car only moves forward because of friction. This is a block and something is kept on the block. When I move this block, ding, 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 this thing also move. Why does this thing move? This moves because of friction. If there is no friction, it will not move, it will just fall. So the bottom line is, friction does not oppose motion. It only opposes relative motion between the two bodies. Wherever there is relative motion, it opposes relative motion. Sometimes there may not be relative motion, but there may be a tendency of relative motion. What do you mean by this tendency of relative motion? Anyone can give an example. What do you mean by this tendency of relative motion? For example, I have this inclined plane, which is inclined at an angle of theta, and it is very rough. Now on, things are going to be rough and they are not going to be smooth. It is very rough and you have a very heavy block kept on the top of this. But many times you will find that this block does not move. I can give you an example. This is a rough surface, and I keep inclined like this, and I keep something on it. What do I keep? I keep this on it. See, even if it is inclined, oops, this is too smooth. Even if it is inclined, see, it is not moving. See, it is not moving. It is at rest. There is no relative motion between this surface and this pen. I mean, it is very smooth. That is why I can't create a more rough surface. See, there is, oops, it's just too rough. This is just too smooth. This would be a better option. Yes, you see this. See, it is kept on an incline, but it is not moving. There is no relative motion between this incline that I have created and this block. We had seen that if there was no friction, this block would have just moved down with an acceleration. With how much acceleration this block will move if there was no friction? Yes. With how much acceleration the block will move if there was no friction? Tell me. We have done that many times. See, we have forgotten.
mg sin theta.
Mg sin theta cannot be acceleration. It is force. Dimensionally, your answer is wrong. Try again. See, remember, this is physics. This physics is problematic. Why it is problematic? Because as soon as one chapter gets over and we think that, even if we don't understand anything in this, life is going to be smooth, it does not happen that way. Because whatever we have learned in the previous chapter is going to come in the next one. That is the problem with physics. So if you don't remember anything that we have done before, the entire physics will go down the hill very soon. I'll give you 2 minutes. Go back. Tell me what is the acceleration.
G sin theta.
G sin theta. Chalo. Thank God. G sin theta is the acceleration, but you can see this block does not move. I have shown you. That means the block is at rest. But even though the block is at rest, it has a tendency to move. It wants to move. Where does it want to move? It wants to move here, down the inclined plane. It is not moving. Something is stopping it. Something is stopping the relative motion between the block and the incline. And who is that thing which is stopping the relative
Frictional
motion?
force.
That is friction. So even though there is no relative motion, there can be a tendency of relative motion. More simpler example. I have a very rough floor and I have a very heavy block and I apply a very small force F, very huge almirah. It's a rough surface and I try to apply a force. It does not move. It wants to move. It does not move. It is at rest. It is at rest, but it wants to move. Where it wants to move? It wants to move in this direction. So there is a tendency of motion in the right direction. In example number 2, there is a tendency of motion in the rightward direction. In example number 1, there is a tendency of motion in the downward direction, but the motion is not happening. The relative motion is not happening. Something is stopping it. The thing that is stopping it is friction. And that is what we understand by friction. Friction is the parallel component of contact force. And the only purpose that it is going to serve is that it is going to oppose relative motion if there is relative motion, or it will oppose the tendency of relative motion if there is no relative motion, but there is a tendency. Remember, friction never opposes motion. In fact, it is because of friction motion is possible. It's because of friction between Your body and your desk on which you are sitting, bench you are sitting. That's why you can sit. You cannot sit on an ice slab because you will slip. Motion is not opposed by friction. It only opposes relative motion. Do we understand this? Yes or no? Understand this? Now, as soon as we understand this, then comes the next point, and the next point is known as the angle of friction. What do you mean by this angle of friction? What do you mean by this angle of friction? So we again go back to the diagram that I had drawn. Two bodies are kept in contact. In this case, there is also relative motion. They exert forces on each other. Reaction force or contact force, R, is that reaction force or contact force. That force has been resolved into two components, the normal contact force and friction. This reaction force is going to make an angle with the normal reaction force. This angle theta is known as your angle of friction. Theta is known as the angle of friction. Angle of friction. So angle of friction is the angle between what?
Normal and contact force.
Between normal contact force and the reaction force R. And how will you find out this angle? Tan theta of this angle would be equal to your F divided by N, where F stands for your frictional force and N stands for your normal reaction force. Do we understand this? This is from vectors. We have done it so many times. Also from vectors, I can write this reaction force R in the vector form. It has got two components. In this case, F, the frictional force component is along I, and this normal force component is along J. The angle of this reaction force with the normal reaction is known as the contact name, the angle of friction. And if I have to find out the magnitude of reaction force, I can find it out by under root of x square plus y square, f square plus n square. This is your reaction force. Or sometimes ask you, someone sometimes ask you, what is the value of R? The force between the body and the plane or the incline. It is not normal reaction force only. It is not friction only. It is under root of f square plus n square. Do we understand this? Huh? It has gone above other thing. Bye bye. Bye bye. Bye bye. I'm going. Don't stop me. Huh? Okay, I'll give you a minute to write it. Once you're done, please let me know.
Completed, sir.
Everyone complete it?
No, sir. No, sir.
Okay, okay. Write it. Don't worry. I will wait. Let me know once you are done.
Completed.
Okay. Now, since we have understood what is meant by friction, we can move ahead and see what could be the types of friction that we are going to see. Yes, any idea? Huh?
Static friction, rolling friction, kinetic friction.
Static friction, rolling friction, and kinetic friction. Okay. So one type of friction is known as static. The other type of friction is known as kinetic. Now, when does static friction come into the picture and when does kinetic friction come into the picture? Whenever there is no relative motion, but there is a tendency but the relative motion can happen, relative motion wants to happen, then the friction force acting on the body or between the two bodies is known as kinetic friction. Then static friction. Then when will kinetic friction come into the picture? When there is relative motion between the two. Whenever two bodies are moving with respect to each other, then the friction between them would be known as kinetic friction. Do we understand this? Yes or no? You understand this? Yes or no? Now, in this kinetic friction, we can have two types of friction. The first one is known as sliding friction, and the second one is known as your rolling friction. Now, this rolling friction particularly is not in your course, so we will not be discussing this rolling friction because it is not in your course, but from the only thing that we are going to study in this particular course, in this particular chapter, would be sliding friction in kinetic friction, and we would be studying the static friction. So basically we would be studying static friction and we will be studying the sliding friction. The sliding friction comes under kinetic friction, so many books will say that we are studying kinetic friction. There is only one more type of kinetic friction, which is rolling friction, which we are not going to study. So these are the two things that we are going to study: the static friction and the sliding friction. Now, can you tell me what will you mean by sliding friction? Physics is very simple because the what the meaning of the term is hidden in the term itself. There are no hidden things. You understand the term and you understand the meaning of the term and what is that term going to do. So what do you mean by sliding friction? Yes. Sliding friction is the friction that is going to happen when a body is sliding over the other body. The case that we saw just now here, there was a block which was kept on a surface and it was sliding on the surface. The friction between the block and the body was sliding friction. Do we understand this? This is what we call as the sliding friction. When a block is sliding over a surface or two blocks are sliding over one another, that friction would be known as sliding friction, which is what we are going to study in this chapter. Then once you know what is sliding friction, can you tell me what will be rolling friction? It's cousin brother. Huh? When bodies are rolling over each other. A disc, a wheel is rolling over the ground. The friction between the body and the surface is known as the rolling friction. Do we understand this? That is known as rolling friction. Now you must have heard that two things you would have heard, that rolling friction is less than sliding friction. Have you heard this? Yes or no? For example, if you have to pull or push a block over a surface, it is very tough to push that block over the surface. But then if you put some sort of wheels or some sort of round blocks or round tree or round bamboo sticks below the box, it is easier to move it. Rolling friction is always less than the sliding friction. Do we understand this? Yes or no? So it easier to move. You might have seen sometimes when you go on a plane or a train and you have all these shopping carts. Shopping carts has wheels. It's not slides on the surface. Why do they have wheels? So that it is easier to move them. That is your sliding or rolling friction. Rolling friction we are not going to study. Then what we are going to study? Then what we are going to study? Have you noted it down? Yes or no? No, yes. Shall we move
No,
ideally?
no, sir.
No, sir.
Okay, let me know once you're done.
Completed, sir.
Boys,
No, sir. No, sir.
I'm waiting. Don't worry. Don't worry. Let me know once you're done with it.
Completed, sir.
Everyone done? Shall we move ahead?
Yes, sir.
Okay, so the friction that we are going to study would be kinetic, and in kinetic, we are only going to study sliding friction. So whenever I say kinetic friction, I basically mean your sliding friction. Now, when does this kinetic or sliding friction comes into the picture? This kinetic friction or static friction or kinetic friction or sliding friction, which we will represent by Fk. This Fk comes into the picture. Fk is the friction between two bodies. When there is relative motion, whenever there is relative motion between the two bodies, and here by relative motion, we will mean that the bodies are sliding over each other. The friction between the two bodies is known as kinetic friction. What does kinetic friction do? Fk opposes. What does it oppose?
Relative motion.
It opposes the relative motion between the two bodies, Rm. It opposes the relative motion between the bodies. Remember, it does not oppose motion. It opposes the relative motion that is happening between the bodies. Now, whenever we talk about friction, friction is a force. So whenever we talk about force or any vector, we must be concerned. We must be talking about two things. What are the two things that we must think about and understand?
Magnitude and direction.
Magnitude and direction. So, first of all, the direction of Fk would be such that it opposes the relative motion. Remember, Fk is an action reaction force. So friction would be applied on both the bodies. Same in magnitude, but opposite in direction. Do we understand this? Yes or no? The direction of sliding friction or kinetic friction would be such that it will oppose the relative motion between the two bodies. And you must understand the direction of this friction would be such that it will oppose what? It will oppose the sliding or the relative motion. For example, if this is a surface and a block of mass m, let us say, is moving with a velocity v, and now from now onwards this surface is going to be rough, not smooth. What will be the direction of what type of friction will act? That is the first case. Obviously, that would be kinetic. Fk. What would be the direction of this frictional force? The direction of frictional force should be such that it opposes the relative motion. Remember,
Opposite to velocity.
in this case, it would be on the block. The friction would be going in the backward direction. But what about the frictional force on the surface, on the ground? In which direction the frictional force will be acting on the ground? On the ground, it would be acting in the forward direction. Same magnitude, but opposite in direction. Do we understand this? Yes or no? Okay. Let us now think about one more example. Now there are two blocks. One is the blue block, which is lying below, and the other one is the green block, which is on the top of the blue block. Remember, all the surfaces are rough. So there is friction between this and this. This surface is rough. And there is friction between this and ground. This surface is also rough. Let us say this blue block is moving. Again, I'm talking about velocities with respect to ground. With respect to ground, this blue block is moving with a velocity of 5 meters per second. And this green block with respect to ground is moving with, let us say, 10 meters per second. Talking about both the velocities with respect to ground. Can you tell me the direction of frictional force on the two blocks?
Sir, M1 block will move forward, sir.
I hope you have understood the question. The question is, what is the direction of frictional force on the two blocks?
Sir, left side, sir.
Who will apply that force on the block? I'll give you 2 minutes to think about it and give me the answer. Okay, I hope everyone has thought about it. Now let us see what would be the direction of frictional force on the two blocks. M1 block. If I stand on ground, there is friction between ground and M1 block. With respect to the ground, M1 block is moving forward. So what will ground do? Ground will apply a force in the backward direction. This is F1, which is the force applied by, frictional force applied by ground on M1. So this M1 will also apply the same frictional force. It will be in the forward direction F1. Do we understand this? Yes or no? But on the top of M1, there is also a block M2. There will be frictional force between the block M1 and M2 also. The magnitude would be different, the direction would be different. Can you tell me what are the directions of frictional force between M1 and M2?
Sir, M2 block left side, sir.
So now I have to see with respect to M1, what is happening with M2? M1 is moving with 5 meter per second. M2 is moving 10 meter per second with respect to ground. So if I become M1, M2 will move forward. If I become M1, M2 will move forward because my velocity is less and M2 velocity is more. So when I become M1, M2 moves forward. So what will I do? I will apply a force F2 backwards onto it. So this F2 is the frictional force applied by M1 on M2. But what will M2 do? Okay, you apply F2 on me. I will also, oops, wrong color. You apply F2 on me. I will also apply F2 on you. So he applies F2, but his F2 would be in the forward direction because M1 has applied force in the reverse direction. Do we understand this? So this is how you can find out the direction of frictional force between the blocks. Who is applying how much force? We are not talking about the magnitude. Magnitude we will talk about in the next class. We're only talking about the direction. Do we understand the directions here? Chalo then. I'll give one more. This is block M1. All the velocities are given with respect to ground. It's moving with respect to ground. This M2 is moving with a velocity of 5 meters per second with respect to ground. And then there is M3 on the top of this. It is moving on this side with a velocity of 2 meters per second with respect to ground. All velocities are given with respect to ground. All the surfaces are rough. You have to find out the direction of frictional forces acting on each block, and I'll give you 2 minutes to do this. Think and then give the answer. Is everyone ready with their answers? Shall we begin? You want more time? Okay, 1 more minute. Okay. So let us now draw the direction of forces, frictional forces on the 3 blocks. Let us start with the lowest block. There is friction between the lowest block and ground. With respect to ground, the lowest block is moving forward. So the frictional force will be backwards on the lowest block and forwards on the ground. That will be F1. We all understand this? Now I look at between M1 and M2. If I become M1, how does M2 look? Or if I become M2, how does M1 look? Doesn't matter, both is same. The direction of frictional force will be same. If I become M1, how is M2 moving now? M2 will be moving backwards, yes or no? So frictional force which M1 will apply on M2 would be forwards. Do we understand this? So this F2 becomes the frictional force applied by M1 on M2. Do we understand this? So in which direction will M2 apply force on M1? M1 is applied in the forward direction, so M2 will apply in the reverse direction. So this F2 becomes the force applied by M2 on M1. Now I look at between M2 and M3. If I become M2, M3 will be going left. If I become M3, M2 will be going right. Doesn't matter how you look at it. So if I become M2, M3 will be going towards left. So M2 will apply a force on the right direction on M3, and M3 will apply a force in the left direction on M2. We understand this? This is how we find out the direction of force applied by different bodies on each other. Remember, it does not depend on which direction they are moving. It basically depends on how they are moving with respect to each other. Yes or no? No, yes? We have to see how they are moving with respect to each other and then find out what will be the direction of frictional force. It has got nothing to do with force. There may be force, there may not be force. It depends on the direction of their relative motion. Everyone understands this? We'll move ahead with this friction. In the next class, we'll try to see about the magnitude of kinetic friction. Once you understand the magnitude, once you understand the direction, everything else becomes very simple. So I'll see you in the next class. Take care. God bless all of you.
Bye bye.
Everyone understood what we have done today?
Yes, sir.
Okay.
Thank you, sir.
Bye, sir. Thank you.